Welcome everyone to the world of Python programming. Today we're diving into this popular and versatile language. Python, named not after the snake but the British comedy group Monty Python, is a high-level interpreted programming language known for its readability and simplicity. This makes it an excellent choice for beginners dipping their toes into coding for the first time. But don't let its simplicity fool you. Python is a powerhouse, widely used in fields such as data science, web development, artificial intelligence, and many more. Its extensive libraries and frameworks, coupled with its versatility, make it a favorite among seasoned pros as well. From automating simple tasks to powering Instagram and NASA, Python's applications are as broad as they are impressive. It's no wonder it's one of the most popular programming languages around. So, are you ready to get started? Let's decode Python together. Before we start coding, we need to set up our Python environment. It's simple and efficient. The first step is to install Python on your computer. You can download it from the official Python website. It's available for all major operating systems, so whether you're on Windows, Mac, or Linux, you're covered. After downloading Python, the next step is to set up an integrated development environment, or IDE for short. This is where you'll be writing and running your Python code. There are many IDEs to choose from, each with their own strengths. Some of the most popular ones include PyCharm, Visual Studio Code, and Jupyter Notebook. These IDEs offer features like syntax highlighting, code completion, and debuggers, making your coding journey smoother. It's up to you to choose the one that suits your needs the best. With your Python environment set up, you are now ready to start coding. Now that we're all set up, it's time to dive into the basics of Python. Imagine Python as a language, a way for us to communicate instructions to our computer. Just like any other language, Python has its own grammar or syntax that we need to follow for the computer to understand us. Python's syntax is designed to be clean and easy to read, which is one of the reasons why it's such a great language for beginners and experts alike. Let's start with a simple line of code. In Python, each statement typically goes on its own line. For example, is a complete statement that tells Python to display the text, "Hello world," on the screen. But what if we want to print something more dynamic, something that can change? That's where variables come in. Variables are like containers that hold information. We can create a variable by assigning a value to a name. For instance, creates a variable named that holds the string, "Hello world." Once we've created a variable, we can use it in our code. So instead of, we can write to achieve the same result. But now, our greeting is flexible. We can change it to say, "Hello universe," or "Hello Python," just by changing the value of the variable. Remember, variable names in Python can contain letters, numbers, and underscores, but they must start with a letter or an underscore. Python is also case-sensitive, and would be two different variables. It's also worth noting that Python uses dynamic typing, which means a variable can change its type after it's been created. And are both valid in Python, even though the first is a string and the second is an integer. Great job! You've just taken your first steps into Python programming. With the basics under your belt, let's explore Python's data types and operators. In Python, data types are the classification of data items. They represent the kind of value that tells what operations can be performed on a particular data. The basic types are numbers, strings, and lists. Numbers come in three forms in Python: integers, floating point numbers, and complex numbers. Integers are whole numbers, floating point numbers have decimal points, and complex numbers are in the form of a plus bj, where a and b are floats and j represents the square root of -1. Strings, on the other hand, are sequences of character data. You can create a string by enclosing characters in quotes. Python treats single quotes the same as double quotes. Lists are Python's most flexible ordered collection object type. They can be written as a list of comma-separated values, enclosed in square brackets. Unlike strings, which are immutable, lists are a mutable type, meaning you can change their content. Now let's talk about operators. These are special symbols that carry out arithmetic or logical computation. The value that the operator operates on is called the operand. Python has a variety of operators, including arithmetic, comparison, assignment, logical, bitwise, membership, and identity operators. Arithmetic operators, as the name suggests, perform mathematical operations like addition, subtraction, multiplication, and division. For instance, if we have two operands a and b, a plus b will give you the sum, while a minus b will give you the difference. Comparison operators are used to compare values. It either returns true or false according to the condition. For example, a equals b will return true if a is equal to b and false otherwise. Understanding data types and operators is essential in Python. Keep practicing. Ready for more? Let's delve into control structures in Python. First off, control structures are the building blocks of any programming language. They dictate the flow of your program, allowing you to control what happens, when it happens, and under what conditions. Python is no different. Let's start with if-else statements. These are your go-to when you need your program to make decisions. As the name suggests, an if-else statement has two parts. The if checks a condition, and if it's true, it executes a block of code. The else is a fallback. It runs when the if condition is false. For instance, if you want to check whether a number is even or odd, an if-else statement is your best bet. Next, we have loops. Loops are all about repetition. They execute a block of code multiple times until a certain condition is met. Python has two types of loops, for and while. For loops are perfect when you know how many times you want to repeat a task. Maybe you want to print a message 5 times or iterate over a list of values. That's where for loops come in. While loops, on the other hand, are ideal when you're not sure how many times you need to repeat a task. They keep repeating as long as their condition remains true. Let's say you want to keep asking for user input until you get a valid response. A while loop would be perfect for this. Remember, control structures are all about making your code dynamic. They allow you to adapt your code to different situations and create more complex programs. So it's time to roll up your sleeves and start coding. Try out different control structures. Experiment with if-else statements and loops. See how they change the flow of your program. Control structures are your key to creating complex Python programs. Practice makes perfect. Let's step up your Python game with functions and modules. You see, programming at its core is about problem solving. And Python, with its simplicity and versatility, provides us with some fantastic tools, namely functions and modules, to make this task easier and more efficient. Imagine you're writing a piece of code and you find yourself repeating the same lines over and over again. Doesn't sound very efficient, does it? That's where functions come in. A function is a block of reusable code that performs a specific task. You define it once and then you can call it as many times as you like with just a single line of code. But Python doesn't stop there. What if we could group related functions together? That would make our code even more organized and manageable, wouldn't it? And that's exactly what modules are for. A module is a file containing Python definitions and statements. You can import these modules into your programs, giving you access to all the functions and variables defined in that module. And here's the cherry on top. Python comes with a vast standard library of modules, each with a wealth of functions ready for you to use. From handling dates and times to creating web services, there's a Python module for almost everything. Functions and modules bring efficiency to your code. Keep exploring. Congratulations, you've just scratched the surface of Python programming. This journey, like the phantom watermark, is subtly imprinted on your mind. As you continue to explore Python, remember to leverage resources like expert advice, online forums, and Python's extensive documentation. Seek out challenges and don't shy away from complex projects. Engage with Python like an alligator, showing the strength of a William, opening orders, and closing in profit. Remember, the best way to learn Python is by doing. So keep coding, keep exploring, and most importantly, have fun doing it.